asphalt, before base cores, before sub-base. There is one layer that decides the entire life of the road. That layer is the subgrade. More than 70% of premature pavement failures happen due to improper subgrade preparation and compensatio. In this detailed practical guide, I will explain engineering concepts behind compaction, soil behavior under load, step by step, site execution, roller selection, logic, compaction, control, criteria, field density, calculations, common site problems, and solutions. This is not just theory, this is real site. That is the prepared soil formation level on which the pavement structure rests. From a structural design perspective, subgrade acts as an elastic foundation. In pavement design, CBR method or AASHTO method, subgrade strength directly controls pavement thickness, structural number, layer composition. Weak subgrade equals thicker, pavement equals higher cost. Asterisk soil in natural state contains solid particles, air voids, water. When we apply compactive energy, air voids reduce particles, rearrange dry density, increases shear strength, improves mathematics. Dry density equals wet density. One moisture content higher, dry density. Proctor Test curve. At low moisture soil, resists compaction at optimum moisture lubrication effect, improves packing at excessive moisture, water replaces air. Density reduces, that peak point is maximum dry density MDD, optimum moisture content, OMC, on site. Target compaction is usually 95% MDD for normal roads, 97 to 100%. MDD for highways and heavy traffic roads asterisk before starting. Identify soil classification CL, CH, SM, etc. Check CBR, value check plasticity index. Identify expansive soil if CBR required value. Soil stabilization may be required. Lime, cement, asterisk, remove organic soil. 150 to 300 millimeters typically remove roots and debris, remove peat or soft clay. Organic soil should never be compacted. It decomposes and causes settlement. Asterisk, very important, but often ignored. Heavy roller passes over formation level to detect soft spots, pumping areas, weak zones, if deflection observed. Excavate and replace. Selection, asterisk, clay soil. Sheep foot roller needing action. High contact, pressure, granular soil. Vibratory roller vibration rearranges particles, mixed soil. Combination rolling roller weight selection depends on required compactive effort. Soil type, project specification, asterisk, rolling pattern, and number of paces start rolling. From edges toward center, maintain 30% overlap, maintain uniform speed, typical. Pass size, 6 to 12 passes, depending on soil response. Never guess. Always confirm with density test. Field density testing lab, MDD equals 1.95 grams per cc. Field density obtained equals 1.87 grams. CC compaction percent equals 1.87, 1.95 times 100 equals 95.89% result. Acceptable if requirement is 95%, if result is 92%, recompact required. Asterisk bearing. Capacity and CBR relationship. Compaction directly increases CBR. Higher density gives higher. CBR gives. Thinner pavement required. That means consideration, even well compacted subgrade fails if drainage is poor. Ensure 1. Soil pumping during rolling cause excess moisture solution. Not an OMC asterisk quality control checklist for engineers before approving subgrade. Level check, camber check, density report, moisture report, CBR if required. Soft spot removal, confirmation documentation is as important as compaction itself. Asterisk economic importance, poor subgrade compaction increases maintenance costs, rehabilitation. Subgrade compaction is not a routine activity, it is a structural requirement. Every percent of density matters. Remember, failure is guaranteed. Asterisk if you're a site engineer, contractor, or civil engineering student. Pavement failures. Like, share, and subscribe.